Welcome to this first video of lesson Similarity, which is the first lesson of Mathematics Part 2 of Standard 10. The name of the lesson is Similarity, but as a first point in this we are going to learn about ratios of areas of two triangles. Okay, this is the first thing which we are going to learn under this lesson, Similarity. Ratio of areas of two triangles. Here we know certain basic concepts. Let's recall that basic concept. Here we are using two words. The first word is ratio and the another word is area of two triangles. So let's recall about these two concepts, ratio and area of a triangle. Let's go for what is the meaning of ratio. Okay, comparing two positive real numbers by division is called a ratio. So in which case we need to compare, and how can we compare? For example, there is a student A who has got 10 marks out of say 20 marks, and student B who has got 20 marks out of 20. So how can we compare these marks? How can we do this comparison? So this comparison we can do by two methods. First is by subtraction or finding difference, or the another method is finding by division. Means what? Means if we find the subtraction, do the subtraction and find the difference between their marks is 20 minus 10. The difference is 10. Okay. If here there are marks, so we are talking about out of these marks. Now these marks are not very much important here. We are talking about 10 marks and 20. So we are comparing these two positive numbers 10 and 20. Okay, how? So first by taking difference means we can say that student B has got 10 marks more than A, or in other way we can say student A got 10 marks less than B. Okay, as 10 is lesser than 20 we can say, and the difference is again 10. This is the 10. If the numbers are different, we can get say 10 and 15, then we can say the difference is 5. And A child got 5 marks less, or B child got 5 marks more, like that. And that what is the another way of finding comparison? That is division. Means if we divide this number 10 and 20, if I divide marks of A with marks of B, then the fraction is going to be 1 upon 2. Means we can say that A has got half marks of whatever marks B has got. And if we do in other way, if we divide 20 by 10, we can get it 2. So we can say B child has got 2 times marks of child A. So this is the other two way of finding comparison or doing comparison. One by subtraction and one by division. And what is the meaning of ratio? Ratio is comparing two positive real numbers by division. So we are seeing how to divide this and get it this. So what is the ratio of 10 and 20? Okay, 10 and 20, or 10 to 20 we can say 10 to 20. So the ratio is written as 10 divided by 20, that is 1 upon 2. Now this we can write it as either by numerator denominator form or 10 is to 20, which whose reduced form can be 1 upon 2, that is 1 is to 2. Okay, so the ratio is written either using by division or using colon between this. So what is the ratio of A and B? It can be written as A is to B or A upon B. So this is the meaning of ratio. Okay. Now let's come to the another top point in this contest, that is area of a triangle. Here you will say, what is a very difficult thing? We know that area of a triangle is half into base into height. But many times students get confused to get proper base and proper height. So let's recall this concept quickly. So what is the formula? It is half into base into height. With using this formula, you can find the area of the triangle. Very true. But what is the meaning of base? What is the base and what is the height? Now what is base? Now base is any side of triangle can be taken as a base. And what is the corresponding height? The height should be correspond to the base. Okay. So the length of a perpendicular drawn from the opposite vertex of the side is called the height. Means for example, for a triangle ABC, these are the three vertices A, B and C. So it has three sides AB, BC and AC. So let's take, suppose AB as a base. Okay. What is this AB side, and what should be the height? If you are taking AB as a base, the height should be its opposite vertex. What is the opposite vertex of AB side? It is, you just hide this AB, you will get the vertex is C from C, which is the perpendicular drawn here. So it is CF. So corresponding height will be CF. So if you are taking AB as a base, then the height is CF. Okay. Then what is the another side of triangle ABC? Suppose you are taking it BC. Then what is the height? If BC is the side you have taken, then the opposite vertex is A. And for BC side you have to take the height, which is going to be A from this perpendicular, it is AD. So if your base is BC, then height should be always taken to be the perpendicular drawn from its opposite vertex, that is AD. And if you want to take AC as a base, then what is the height for this base? So its opposite vertex is B. From here, what is the perpendicular drawn? It is BE. Then the BE is going to be the height of the triangle. Is that clear? So it is not always that, it is generally misunderstood that only this side should be taken as base and this should be the height. Yes, it is base and corresponding height, but it is not always to take as the side of the triangle which is drawn horizontal should be taken as base. Even this side can be also taken as a base, and then the corresponding height will be CF. And for this AC side, B is going to be the height. Okay. So when we understand these three basic concepts which we have learned in the previous classes, let's see now what is the area of ratios of areas of two triangles. Okay. For this, let's draw two different triangles. Say triangle ABC, which can be acute angle triangle. Suppose this is another triangle, or say obtuse angle triangle, say PQR. Okay. Now if you want to take BC as a height, as generally we take, then its opposite vertex is A. From this we need to draw a perpendicular here. Say this perpendicular drawn is AD. And now if you want to take this as base of the another triangle PQR, then perpendicular should be drawn from P. Now you can see it is not meeting to your QR base, so it should be extended this, and when it is extended and here it meets, so this named as PS. Okay. So in triangle, let's write here, in triangle ABC, AD is perpendicular to BC, and in triangle PQR, say PS is perpendicular to QR, side QR. Okay. So if we take this as base, it's going to be height, and when you're going to take QR as a base, it's going to be height. Okay. Therefore, we can say base BC, which is the first triangle, to be taken as B1, and height AD, which can be taken as 1, because this is fifth triangle number 1 ABC, and this is in triangle number 2. So base BC we are assuming is B1, and this is height 1, and this base we are considering as base 2, which is the base of the second triangle, and this is height of the second triangle H2. Okay. And let base QR is equal to B2 and height PS is equal to H2. Now as we want to take ratio of areas of two triangles, it means we have to divide area of triangle ABC by area of triangle PQR. As we want ratio, and ratio is comparing the two numbers by division. So area is a number, the area of first triangle upon area of triangle, second triangle, we are dividing these two, means we are taking ratio of them. It is equal to, let's put the formula here. So half into, what is the base? Base of this triangle, we are taking BC, and height is what? AD. corresponding height is AD. Upon, what is the formula here? Substitute that formula here. Half into base QR into height PS. Correct? Yes, this QR base and the height is PS. Okay, if you see this, you can see that half can get cancelled. So you can get this as BC into AD upon QR into PS. Okay, so what do you get? Area of these two triangles is equal to, ratio of areas of two triangles is equal to, this is also ratio. What is this ratio? This is the ratio of product of base into its corresponding height. Here also base into corresponding height. So if you mention this area, say as A1, this area of the first triangle, and area of the second triangle, it can be written as product of base 1 into height 1. BC is B1 and AD is H1. So product of base 1 into base height 1. And here QR is what? B2 and TS is H2. B2 into H2. So we have got this first property, that ratio of areas of two triangles is equal to ratio of products of their bases and corresponding heights. Okay, so this is the first property we have got. Now from this property we have to see three more conditions in that what if. Okay, so this is the property number 1 we have understood. Now for the second situation, now if bases are B1 and B2 are equal, then what will happen? Then what will be A1 upon A2? If B1 and B2 its values are same, its bases are same, then automatically this will also get cancelled and it remains only H1 upon H2. Okay. So if bases are, two triangles are equal, if BC and QR its length are equal, then we will get the area, ratio of their areas is going to be equal to the ratio of their corresponding heights. So this is the second property. Now the third property is what? If heights are same, if H1 and H2 are equal, say if length of AD and length of PS, these two heights are equal, what will happen? Now when heights are equal, the heights will get cancelled and it will remain that A1 upon A2, that is ratios of areas of two triangles, will be equal to the B1 upon B2. It means this ratio of their areas will be equal to ratio of their corresponding bases. So students, when bases are equal, ratios of areas are equal to the ratios of heights. And when heights are equal, ratios of areas are equal to the bases. And with both are different, that we are taking the products. And what if we are having both equal? If base also equal and height also equal, H1, H2 are also equal, then this base will get cancelled with base and height will get cancelled with height. But then what will remain? It will remain 1. And when you cancel like this, it remains 1, 1, 1, 1. So then in that case, A1 upon A2, this ratio is going to be 1 upon 1 or equal to 1. Or in other words, you can say A1 is going to be equal to A2. These two values are going to be equal. So this is the first part of the lesson, similarity, where we have learned what is the meaning of ratio of areas of two similar triangles, and that these ratios of areas of two triangles. Here we are not using any word similarity or similar, just two triangles, any two triangles. So ratio of their areas is equal to the product of their bases and corresponding heights. And when bases are equal, it's equal to the ratios of their height. When the heights are equal, this ratio is equal to the ratio of their bases. And when both are equal, the ratio is 1. Thank you very much. If you understand this concept well, please give me the likes and comments. And if you are not yet subscribed to the channel, please subscribe. Thank you.